Hello and welcome. This is a presentation of Cero's Business Policy Traffic Engineering demonstration. Our purpose today is to demonstrate Cero's system integration capabilities. In this demonstration, we use automation tools to optimize an operational workflow. The operational task is required to control costs to the business. The policy framework uses business logic to make decisions. The operational environment is evaluated frequently to track and measure changes in resource utilization. Based upon the business rules, the current operating condition, the system recommends network changes to meet the business goal. We'll demonstrate the framework with a common use case. In this instance of the framework, we call the framework Pop Manager. In this use case, an application service provider has several ISP connections to their data center. Each ISP has their own pricing structures and SLAs. These pricing structures are commonly billed for usage over an entire month. Keeping track of these details and avoiding overages is complex and cumbersome, but very important to the business. The integrated framework is able to input the parameters of these ISP agreements and pricing structures, track actual utilization over time, and make or recommend network changes to avoid overage charges. Within the context of the use case, let's take a look at the type of change the framework would make with this illustration. The before section of the illustration shows traffic entering the data center using ISP C and exiting the data center using ISP A and C. The system predicts that at the rate resources are being used on ISP C, the overage cost is going to occur in the near future. To avoid this overage cost, the system recommends moving all traffic to enter and exit the data center using ISP A. The after section of the illustration shows this change. The dynamic changes outlined in our use case of moving traffic between two ISPs occurs within the Action Manager component of the framework. The Action Manager displays the recommended actions that result from policy and utilization data processing and is capable of recommending changes to the system as real-time situations evolve. Operators do not worry about ISP billing structures, billing cycles, and complex routing protocol configuration details. Operators only need to evaluate recommendations and authorize the changes. In order to address the use case and provide a solution, the framework must accomplish several objectives. The first is to measure, track, and compare circuit utilization for each ISP. How the system accomplishes this is visible on the burst budget consumption page of Pop Manager's UI. Let's take a look at the user interface and see how it measures, tracks, and analyzes the bandwidth resources for each ISP. Looking at the chart on the left for ISP NTT, this chart represents a full 30-day billing cycle. The vertical y-axis is minutes of bursts above the service contract rate. The horizontal x-axis is day of billing cycle. The horizontal line, in red at the moment, is the threshold of burst minutes for this ISP service for this billing cycle. The diagonal line, red at the moment, is the projected burst minutes over time. Where this line intersects with the burst threshold is where overage charges are predicted to occur in time. The diagonal green line represents the maximum burst minute utilization rate over the entire billing cycle, which will not incur overage. If the system projects that an overage is going to occur, the system may recommend moving specific network traffic to another ISP to avoid the overage. In this case, the projection is that the overage is going to occur for this ISP. The second objective is to determine what to do in case of a projected overage. The burst traffic composition table visualizes how the system can make this type of decision. Top 10 destinations for the ISP are broken down and displayed. By identifying the composition of bandwidth utilized by the system can plan to manipulate routing to affect the utilization rates of ISP circuits. If an overage is going to occur, it is helpful to know which network destinations are consuming the most bandwidth. For example, prefixes with high burst utilization can be identified if the data flow needs to be moved to avoid the overage costs. This screen is the Action Manager. The Action Manager shows the culmination of Cero's policy automation framework and represents the final objective needed to realize the goal of the use case. If a high traffic prefix needs to be moved from one ISP to another, this is where we can see Action Manager recommending the change. Action Manager can execute the recommended change with or without human intervention. As we can see by looking at Action Manager, it is currently recommending changes. The operator can review the change and decide whether or not to push the configuration change to the network. This configuration push is done by pressing the blue radio button on the right of the screen that says Commit Check. Action Manager analyzes data in timescales of days, weeks, and months. So finding a specific change event for demonstration purposes is somewhat troublesome. But we can show you that Action Manager and its underlying software infrastructure can manipulate the network in complex ways, but accomplish it simply. We can manually move traffic from one ISP to another, using the exact same controls that Action Manager uses. The purpose of this demonstration is to show our system's integration capabilities actually work. In our demonstration, a data center is connected to several ISPs, including NTT and Level 3. We'll monitor the traffic entering the data center from these ISPs using these terminals. At the top left of the screen, we're monitoring traffic entering Level 3. At the top right, we're monitoring NTT. The bottom terminal is monitoring real-time interactive commands that the framework is sending to the network node. Let's take a look at how the traffic is flowing through these ISPs right now. As we can see from the Level 3 traffic monitor, data flow is moving into the data center from this ISP. The traffic monitor for NTT shows no traffic inbound. For simulation purposes, let's decide to manually move traffic off of Level 3 circuit to the NTT circuit. Let's now go to the POP Manager and make that change. The operator would select Customer Page by clicking on the POP Manager drop-down menu. The operator would then select the customer and click on the Traffic Engineering radio button. The operator can then make changes to the network policy, making one ISP preferred over the others. Let's now move inbound traffic from Level 3 to NTT. We'll commit check to let the system validate the requested changes. The commit check was successful, so we'll go ahead and apply those changes to the network. The commit was successful. The change we just made should transition inbound network traffic from using Level 3 to NTT. Let's verify that the network node received the policy change from the operator. Okay. By looking at the interactive command log, the network node, we see that the node did in fact receive the commands to change the traffic policy. Let's go back to our traffic monitors and check to see if the traffic is now using NTT instead of Level 3. As we can see from the traffic monitor, traffic is now moving into the data center using the NTT circuit. And traffic is no longer entering the data center using Level 3. As mentioned earlier, this change is similar to how the system can dynamically move data flow using Action Manager, as we described in the use case. POP Manager is able to move data flow by using automation or manual processes between ISPs. In summary, today we introduced Cero's automation framework that can utilize predefined business logic to optimize business workflows with automation. We introduced the Action Manager, which can dynamically make changes to the system with or without human intervention. We applied this framework to a use case that requires the Action Manager to alter internet routing paths into an application data center to avoid overage charges. And finally, we showed our integration capabilities with a demonstration that moved data flow between ISP circuits. All of this is important because it allows the business to focus on business policies and neatly hides away the complexity of interdomain routing, ISP billing, and bandwidth cost monitoring. Continuous automated monitoring of business policies removes the need for human intervention when change is needed, saving time and saving money. This concludes our demonstration and presentation. Thank you.